everyone, and welcome to This Is My Architecture. I'm Abby. I'm here with Zen from Zocdoc. Zen, thanks so much for joining me.
Pleasure to be here.
So first off, can you tell me a little bit about what Zocdoc does?
Of course. So Zocdoc is really the patient portal for people to just go in and be able to book appointments with any doctor on our system, as well as see their reviews and see what insurance they take, and a whole host of other things.
So kind of like the online version of me asking you for a recommendation.
Yeah, except with way more information available.
except way better. Except way better. Okay, cool. So one of the most interesting diagrams I've seen here, and possibly because there is nothing on the diagram, we just have a goal here. Can you tell me a little bit about what this goal is less than 100 milliseconds means?
Of course. So at Zocdoc, just like many other startups, we have this historical monolith, which is actually really slow because it's in a relational database system. And so this goal is to make sure that our patients are really getting the fastest experience that they can get at the touch of their fingertips, whether it's web or mobile-based. And so we're basically trying to make all our read access to make all the experiences less than 100 milliseconds.
So what about that patient experience? So when I'm on a page from a doctor, what kind of information are we talking about?
So we're talking about those things that I mentioned that we have, which is reviews and being able to see their profile, their appointments that are available, all the things that allow you to actually go in and interact with the site.
So all your projection type data, the user experience for that should be less than 100 milliseconds.
Exactly.
So can you walk me through your architecture? So how did the process go? How did you get from Monolith to less than 100 milliseconds?
Yeah, so let's start off from the beginning. We have the Monolith, which is kind of, pre-AWS world, but now lives in AWS. And we basically created a change feed system that directly populates into a Kinesis stream. And now the goal of this is to dump into the Kinesis stream really as fast as possible. So it's completely asynchronous, and it's completely unordered going into the system. But in order to make it easily consumable, we do have to order it. So this ends up feeding into a ECS container in Scala that is actually doing a lot of the kind of business logic in order to make sure that the Kinesis stream output is cleaned up. And this goes into another Kinesis stream, which is now cleaner. And
so we have our original unordered Kinesis stream, which is here's everything as fast as possible. We're ordering it with our business logic in this ECS cluster, and then we have our second cleaned up Kinesis stream.
Exactly. And so now this Kinesis stream is completely ordered with all the events necessary, so any dependent events come in the right order.
So I have my second Kinesis stream. It's been cleaned up. How does the contents of that Kinesis stream turn into the projections that we see on the website? What's the logic in between?
Yeah, so this Kinesis stream actually feeds two main different things. One is a DynamoDB table. And so this DynamoDB table is basically a new source of truth similar to what our Monolith data used to represent.
So what I think is interesting is you've basically, you had some things about your Monolith that you really liked. So you had the structure, you had the relational aspect of it, but it was too slow. So you're solving kind of the same problem from a different approach as some other places. So you want that same structure, but you want it much faster and in a different format. So now we have Dynamo, which is just like our old Monolith, but faster and cleaner. What do I do with my data from Dynamo? Does it go straight to the projections, or do I have something else that happens in between?
Yeah, so this, as I mentioned, Kinesis actually feeds two pieces. DynamoDB is one of them, but it also feeds into some Lambda functions. And these Lambda functions basically allow us developers to dynamically create business logic that creates these projections. And the projections that feed off of it are in Elastic Cache. So now, when we're talking about the 100 milliseconds read access, that Elastic Cache is able to actually provide 50 milliseconds to us for all the projections and views that we need.
And it sounds like, so not only have you kind of beaten your goal by a significant margin, but it sounds like this is pretty extensible. So if you're feeding a bunch of data, a bunch of events, and then you can generate Lambda streams off of that, it sounds like you can extend this in pretty much any direction to change your business logic, to have new teams, to go in different directions.
Exactly. So this whole system is now kind of built and allows any team to say, I want a new input of data. So a perfect example is we have a new data feed that we're getting from a client. And that data feed goes and populates Kinesis stream events. And it goes through this whole process. And at the end, we get doctor profiles that are being fed from a different source than our monolith.
Cool. So you've been able to take kind of the same logic and apply it to every single business aspect, and you can keep building on top of that.
Exactly.
Zen, it's been a pleasure. Thank you so much for joining me. And thank you for watching. This is my architecture.